Illustrative Math, Unit 2, Lesson 14 is called What Do You Know About Polynomials? All right, our goal is I can determine what information is needed to sketch a polynomial function given a known factor. All right, so here's our warm-up. G of x is a polynomial. Here are some things we know about it. It has a degree of 3. Both x and x plus 4 are factors of g. It has 2 horizontal intercepts, but only one is negative. Its leading coefficient is negative. What else do we know is true about g of x? Okay, so if you want to pause the video and see if you can try this on your own, go ahead. I'm going to kind of walk you through here. So if it has a degree of 3, okay, let's think here, g of x. If I have x times x plus 4, because we know these are 2 factors, this would only give me x squared. So I'm going to need another factor. But here's the thing. It says it only has 2 horizontal intercepts. So if I put another thing here, and I'll just make something here. Let's say I put minus 3. Okay, that would give me a third horizontal intercept. This one would be x equals 0. This would be negative 4, and this would be 3. Now I have 3 horizontal intercepts. That's too many. So if this factor here is anything else other than x or x plus 4, it's not going to work. So what I can do here is, it's almost like I put x plus 4 here as another factor, which would now make this x times x plus 4 squared. So it has 2 horizontal intercepts, but only one is negative. So this would be negative. This would still be x equals 0. This one would be negative 4. There's my negative. There's my other one that's not negative. It says its leading coefficient is negative, so you need to put a negative somewhere on here, maybe in the front. You can make this negative 1. You can make it negative 2. You can make it negative 3. Any negative number will work, because when I multiply that out, so I'd have to distribute this. So x plus 4, if I made a little box here, that would give me x squared. This would be 4x. This would be 4x, and this would be 16. So it would be negative x times x squared plus 8x plus 16. And then if I distribute that, I get negative x cubed minus 8x squared plus 16x. No, minus 16x, sorry. And that would be my polynomial in standard form or general form. Right there, you got polynomial form. So we know this is the same. We know that this could be factored form. What else do we know? We know the end behavior. We know since it's a negative and odd, the left side goes up, the right side goes down. And we could probably also sketch a graph too. I bet we got enough info here to sketch a real rough graph here. If this is my x-axis and this is my y-axis, I know I'm going to have a y-intercept and x-intercept of 0 because my constant is plus 0. You also know going up here that this is an x-intercept of 0. I also have an x-intercept of negative 4 here. Now, since negative 4 has an even multiplicity right here, it's got a power of 2. I know it's just going to touch it. So it's not going to cross through. So if I were to sketch a rough graph here, I'm going to make it come down, touch, bounce back up, and come down. So we could sketch a very rough graph. I have no idea of knowing what this relative maximum is, but I know that this side's going down on the right, the left side's going up. I got my intercepts. Kind of a lot there. We have a potential equation. It doesn't say that the lead coefficient could be any number here. It just has to be a negative. So a lot of stuff there. Good review. All right, so this is what's called an info gap. And I'm going to just do them together. Normally in class, one student would have the data card, one would have the problem card, and we'd have to work together. The problem card would have to ask questions to answer the question, and the data person would just only give them information that they have. So let's think here. Sketch a polynomial f of x, which has a known factor x minus 9. So what does that tell me? That tells me that positive 9 is an x-intercept. And that's all we know. So I would say, okay, are there other factors? And the question, the person would look at the data card and answer that question from there, okay? Okay, so they're going to look at that and tell me all the info based off of there. So I would, start asking questions. Okay, are there other factors? Do they give me the function? Do they tell me the end behavior? Do they tell me the constant? Do I know any intercepts? Okay, things like that. So let's see here. Let's just see what it has. So the graph has a vertical intercept of 63. So right up here, 63, I'm going to mark that. So the equation is right here. So it's cubic. The degree of the polynomial is 3. We have the whole function. Polynomial has one relative minimum and one relative maximum. And as the value of x gets larger and larger in the positive direction, that's moving to the right, y gets larger and larger in the positive direction as well. So that means I'm going up. So if it's a positive lead coefficient and an odd degree, we know the left side is going to go down. Okay, so I know this side, somewhere down here, it's going to have to cross through the x-axis here. So let's see here. Does it give us any other info? Has one relative minimum and one relative maximum. So they give us this function here. It's not in factored form though. So what we could do is now that we know this function and we know the factor, we could do, you could do long division, or you could make a box to get it factored down. So I think I have an extra one here, squared. Yeah, I have an extra. Whoops. Get that out of there. All right, so I would need an x squared here to get x cubed. That would give me negative 9x squared. I'd need, these have to add up to negative 3, so that's going to be a 6x squared. So x times 6x would give me that, and then this would give me negative 54x. And then over here, this would have to add up to negative 61, so that's going to be negative 7x. So that makes this negative 7. And then I double check, and negative 9 times negative 7 is 63. So then if I get that factored, I got to factor this. X and X, obviously. And then if I did negative 7 and positive 1, that would give me 1x and negative 7x. But that adds up to negative 6, so I got to change the sign. That's got to be a positive, and that's got to be a negative. So 7x minus 1x would give me the 6x right there. So cool. Now I have my other x-intercept. So really, this function is x minus 9, x plus 7, x minus 1. So I now know my other intercepts, so I could put one here at 1, and I could put one here at negative 7. So now I can get this thing sketched a little bit better. So it's going to come down here somewhere, come up here. I don't know where the max is. Somewhere down there like that. All right. Obviously, it's not very, I didn't graph this very well over here because it's kind of hard to do this digitally. There you go. A little bit better. All right. So there you go. There it is, more accurate. Now, all this work that I did right here, I wanted it to be more accurate. I wanted to know what the x-intercepts are. Had you not done that, you could have just kind of ballparked it, but you would have no way of knowing where this relative minimum or relative maximum is. All right, next one. So they give me a factor. So, okay, I'm going to just ask questions. Do they give me the y-intercept? Do they give me a factored function in factored form? Do they give me the function in full polynomial form? What degree is it? Do they give me the end behavior? Do they give me any specific points? Are there any relative maximum or minimum on the graph? Okay, those are the type of questions I'm going to ask. So I'm going to go over here to the info, the data. So this looks like end behavior. As value of x gets larger and larger in the negative direction, the value of y gets larger and larger in the negative. So that means the left side goes down. Okay. If x minus 6 is a factor, we know we have an x-intercept at 6. Here's my equation. The graph has a relative minimum between 4 and 6. So somewhere down here, there's a relative minimum. Okay. The value of the function at x equals 1 is 75. So that's kind of nice. I could plot this here at 1. I'm up here at 75. Oh, my y-intercept is 96. So I'm going to go up here to 96, put my y-intercept. All right, so let's do this. Let's see if I can find the other x-intercepts. This time I'm going to do long division. So I take my x cubed minus 6x squared minus 16x plus 96. And I'm going to divide by my factor, which is x minus 6. So I would need a x squared to get this x cubed. So then I multiply. And then I subtract. So those cancel. And then this becomes minus negative. That becomes plus. So that's gone. So now I can bring down the negative 16x. And then I'll bring down the 96 too because everything canceled. X times negative 16 would give me that. Negative 16x. Multiply. And then I need to do negative 16 times negative 6. What's that? That's positive 96. And then I subtract. And actually those cancel. And then those cancel because it's when you add that extra negative sign there. So, so basically that's saying x minus 6 times x squared minus 16 is my polynomial. And if I want to try to factor that, I like to do a box when it's just a quadratic, when it's x squared. So I need x times x to get that. And then this one's going to be minus 4 and positive 4 because we want them to cancel out. We don't want that middle term with x here. You notice that it's 0x. Those cancel. So my factored form, x minus 6, x plus 4, x minus 4 is my function. So now I can put my x-intercepts at negative 4. And positive 4. We have a relative minimum here. So it looks something like that. Get rid of that. And then this side is going to have to go up. Why? Because I have my 3 x-intercepts here. Let me make that a little smoother. There we go. I have my 3 x-intercepts, so I'm not going to cross again. I'm not going to bounce down because I'd have to come back up. So there it is. All right, next thing. Without letting your partner see, do the following. Write a polynomial of degree 3 or 4 in factored form. Sketch the graph. Rewrite its expression in standard form. So degree 3. So I'm going to say x minus 2, x plus 1, and x. Degree 3, because I'll end up with an x cubed. So I'm going to do degree 3. So that's in factored form. So my x-intercepts are -1 here, +2 here, and then 0. Okay, my end behavior, if I multiply this out, I'm going to get a positive x cubed. So the right side is going to go up, left side goes down. My y-intercept is 0. It's going to go through that point right there at 0. Something like that. Rough sketch. Rewrite it in standard form. So let's do this. Let's multiply these two first. So that give me x squared minus 2x, 1x, -2. If I combine my like terms, I'm going to get x squared minus x minus 2. Distribute the x cubed minus x squared minus 2x. So there's my polynomial in standard form. All right. On a separate sheet of paper, write the standard form of your polynomial along with one of the factors or two of the factors and trade slips with their partners. So my standard form would be x cubed minus x squared minus 2x. And then one of my factors, I'll just put x plus 1 is my factor. And then my partner wants to rewrite it in factor. So he's going to have to either do a box or do long division. Either way, I'll do the box. I'll make a little bit neater box this time. So since it's cubed, I'm going to need three columns. So this is x cubed. And this is 0 here, really, because I don't have a constant. So that's going to be times x squared. These have to add up to -1, so that's going to be minus 2x squared. So I'd have to multiply x by -2x. Multiply these. And then this is going to be 0x. So that would have to be a 0 there as well. So that would leave me, let me double check this, x cubed minus x squared minus 2x. That would work. So I would have x plus 1 times x squared minus 2x. And then since these both have an x that's common, I could pull out my x and just do what's called a greatest common factor there. And there it is. So I like to put the x in the front. And there we go. So we got the same answer that we had originally. It's just in a different order. Same factors, x minus 2, x plus 1, x minus 2, x plus 1. All right. How would you explain to a student who isn't here today how to solve a problem like the one in the info gap, including what questions they think they should ask and any other steps needed to graph the polynomial? Well, I would say you need to ask if there are factors given, x-intercepts, y-intercepts, and behavior, a polynomial function given in factored form or polynomial form, a multiplicity, a specific points given, if the polynomial is given in polynomial form and you have a factor, you can do long division or factor with a box to find the other factors. All right, cool. I can use division to rewrite a polynomial in factored form, starting from a known factor and then sketch what it looks like. So again, remember, just once you have a known factor, do division until you can get it down to linear factors. So here is my polynomial. I have two known factors. Would you use a diagram, long division, or some other method to rewrite the expression for D in factored form? And there's no real right or wrong answer here. I'd probably just do long division here because I need to find the other factor. I know two of them. I know x minus 2. I know x minus 1. I could probably figure it out, though, maybe just kind of by using common sense here, because I know that my constant's got to be 14. So if I multiply -2 times -1, I would need a 7 here. I need a positive 7. And then I know I have to have a 3x squared here. So I know I'm going to have a 3 in the front. So I'm kind of just using a little logic there to figure it out. And then I know that -2 times -1 times 7, that would give me 14. X times 3x, that would give me the 3x squared. So that's probably it. If you wanted to check it with long division, you'd have to do it twice here. I'll start with the x minus 1. Oh, wait, that was supposed to be a cube. Sorry. So I need to multiply that by 3x squared. And then I distribute it. And then I subtract. So these cancel. This ends up being plus, so I get a positive 1x squared. Bring down the next term. X times x. And then I multiply. And then I subtract. This becomes a plus, so I get negative 14x. And then that's minus 14. And then I subtract, and that gets me down to 0 because they cancel. And then I could do it again. This time I'm going to use my other factor. I use the x minus 2. So I need x minus 2 times a 3x. 3x squared minus 6x. Subtract. Cancels that. That becomes 7x. And then x times 7 will give me the 7x. Subtract. And everything cancels out. So there's that other factor that I found. So I did it both ways. I used some other method. I kind of used a little trial and error, what I know about lead coefficient and constants. Did long division. I could do the same thing with the box. All right, so end behavior, multiplicity, these are all things we should know. So, all right, hope you enjoyed the video today. Thanks for watching.